Okay, we're going to continue our discussion here and our delve into an intro to trig, talking about angles and radian measure. We talked about quite a bit of this in class today as we were going through some of the words you knew and thought you knew. So remember we talked about the initial ray, and the initial ray being the one that is on the positive x-axis. The terminal ray is then where the rotation, where the angle stops. And the terminal ray determines what quadrant the angle is in. For example, this angle theta, we would say, lies in the second quadrant. When we are moving in this counterclockwise rotation here around this direction, we say that theta is a positive measurement when we rotate counterclockwise. And when that angle is rotating through here in a clockwise rotation, we say that that angle is negative. So we have the angle alpha being a negative angle because it's rotating in a clockwise rotation. We talked also about a central angle, and remember we talked about a central angle meaning that the vertex of the angle is located at the center of the circle. Okay, so a central angle is an angle whose vertex is the center of a circle, as we have here. We'll call this point P at our center, and P is the vertex of the angle. It is also the center of the circle. We're going to talk quite a bit about radian measure, okay? And radians is what we will use quite a bit more than degrees. It's just another unit of measure for angles. So instead of saying like centimeters and inches when you're talking about length, you have degrees and radians talking about the measures of angles. So how do we determine a radian? Well, a radian, the unit 1 radian, occurs when the measure of the central angle cuts out this arc. So we have this arc that the angle is cutting out of the circle. When the length of that arc is the same as the length of the radius of the circle, notice that that length is the same as the radius. Okay? At that point, we say that theta has a measure of 1 radian. Okay? So 1 radian is a measurement that occurs when the length of the intercepted arc is equal to the length of the radius of the circle. And most everything that we're going to do with this trig is going to be based off of this idea of a radian. Okay. So one of the ways we can kind of relate these things is S represents our arc length, our intercepted arc. Okay. And I'll write this down here, intercepted arc length. Okay. And theta, the measure of theta, the measure of the angle, is equal to the length of the intercepted arc divided by the radius of the circle. Okay? And the one thing we have to make sure of is that the units on our arc length and the units on our radius match. We have to make sure they're the same so that that ratio will simplify out. Okay? So for example, if we say that S, we say our arc length is 2r, then when we have theta equals S over R, that becomes 2R over R, and theta would be 2 radians. Okay? So when the arc length is twice the length of the radius, we'd say that the measure of the angle, the central angle theta, has a measurement of 2 radians. Okay? If it were 3R, then we'd say it would be 3 radians. Okay? So how are degrees and radians related? How do we get those things related to one another? Okay. Well, if I go 1 full rotation around the circle, then the arc length S is going to be equal to 2 pi r, basically the circumference of the circle. And as we saw before, the measure of theta in radians is the arc length divided by the radius. So if our arc length is 2 pi r, and we divide that by the radius, then our radii will divide out, leaving me with theta being 2 pi. Well, we already know from our geometry days that in terms of degrees, 1 rotation around a circle is 360 degrees, which means that 360 degrees is equal to 2 pi radians. And if I were to divide both sides by 2, then 180 degrees is equal to pi radians. And I could go even further and say that 1 radian then would be equal to 180 degrees divided by pi. Okay? So 1 radian is the same as taking 180 degrees and dividing by the value of pi. And this is the key part that's going to allow us to work back and forth and convert back and forth between degrees and radians. Okay, so here's our conversions. If I want to convert from degrees to radians, I'm going to take the degree measure and I'm going to multiply that by pi divided by 180 degrees. And when I do that, I'll end up with an answer in terms of this pi here. And oftentimes we want to leave pi in that answer, and that gives me an angle in radians. If I've got radians and I want to convert it to degrees, then I just take the reciprocal and I take 180 divided by pi. Because remember, 180 and pi are the same thing. We saw on the previous page that 180 degrees is the same thing as pi. So that whole fraction is really just a value of 1. Same thing up here. That whole fraction is really just a value of 1. So I'm not changing the overall value of the angle, I'm just changing the units that it's being written in. And now that would give me something in terms of degrees. Okay. So here's a couple examples. We've got a central angle theta in a circle of radius 12 feet, and it intercepts an arc length of 42 feet. What is the radian measure? Okay. So we remember that the theta is the arc length, the s divided by r. So we plug in our values, 42 over 12. The feet will divide out. Okay. And we have 3.5 radians. Example 2, we're going to convert 30 degrees to radians. So we're going to multiply our 30 degrees by this pi over 180 because that's our conversion factor. Remember, that's really just a value of 1. The degrees will basically divide out. And then we simplify our fraction down and we have pi over 6 radians. So we want to leave those answers in terms of pi most of the time, okay? And pi over 6, we'll see, is one of our special angles that we'll deal with quite a bit throughout the next chapter. Going in the opposite direction, negative 5/3 pi to degrees, we would multiply by 180 divided by pi, and you can see that the pi's here divide out. The 3 and the 180, that would simplify to 60. So I have negative 5 times 60, which gives me the negative 300 degrees. If I think about where that angle is, it would start here at this initial ray, and it would go clockwise, negative 300 degrees. And we use this rotation, this kind of circular arrow around the outside to show the direction of our angle, the direction of our rotation, so that there's no confusion about whether we're talking about this big negative 300 degree angle out here or whether we're talking about the 60 degree angle that would be in between. So we use this arrow around this rotation to show the direction of the rotation of the angle, indicating that it's going to be a negative angle because we're going in a clockwise direction. Okay. So here's some more things to think about. We know that 1 revolution around a circle is going to be 2 pi. So if I think of that matchup and I look at, well, what's a quarter of a revolution? Well, 1/4 of 2 pi would give me pi over 2 radians at my positive y-axis. If I go a half a revolution, I get halfway around the circle here. Well, half of 2 pi would give me pi radians as a measurement on the negative x. When I go 3/4, I get down here to the negative y. 3/4 of 2 gives me 3/2. And then obviously the full rotation gets me around to 2 pi. So that idea of a portion of a revolution and taking that fraction times 2 pi is how we'll get those radian measures for some of the other special angles that we'll see. Okay. So taking that into account, let's think about how we could draw an angle that's pi divided by 4 radians. Okay, so here's my x, here's my y. Okay. We saw in the previous that this would be 0, this would be pi over 2 radians, that's pi, 3 pi over 2, and this is 2 pi radians. So where does pi over 4 fit in? Well, pi over 4 is going to be halfway between 0 and pi over 2. So my angle would actually be this angle right here, theta, that rotates a rotation of pi over 4 radians. Okay? So that angle would lie in the first quadrant. That is where this angle of pi over 4 would reside. Because remember, we're always thinking of the positive x is always our initial ray. That's always our starting point, is the positive x-axis. And we're going to rotate that angle up a positive pi over 4 radians. Okay. Now here's just a quick look and a quick intro at what's called the unit circle. And you can see in the unit circle that in the first quadrant we've got a 30 degree, 45 degree, 60 degree, and their equivalent radian measures. Okay? And we also see on the outside of the circle the coordinates in xy terms, the x and y coordinate, where each of those points would lie on this unit circle. And notice that the radius of this circle is 1 unit. Okay, 1 unit there, 1 unit, 1 unit, 1 unit. So when we talk about the unit circle, we're talking about a circle of radius 1. And all of this stuff in this circle is all stuff that we're going to learn here through chapter 4. And these are all values that you're going to have to know. You're going to have to remember the values for each of these special angles. These are all of our special angles. And we're going to need to know their sines, their cosines, their tangents. And we're going to learn all those things. But it's going to take some work to memorize and remember what those things are. And all these values here in these ordered pairs, they're all going to relate to the sines, cosines, and tangents. Okay? So just a little preview of things to come there. All right. So one of the last things we're going to talk about is coterminal. And again, we kind of talked about this in class a little bit. Coterminal angles have the same initial and terminal ray, but possibly different rotations. So we find coterminal angles by making a full rotation from wherever we already are. So if my theta is in degrees, then I take theta and I add or subtract multiples. The k is just an integer. So we're looking at integer multiples of 360. So I add 360, I add 720, or I subtract 360. Okay? If my angle is in radians, then I'm adding or subtracting multiples of 2 pi to find some other angle that's coterminal, another angle that actually sits in the same position but has a different measurement. So, find one positive and one negative angle coterminal with each of these given angles. So if I look at part A, if I've got 50 degrees, I would add 360 degrees to that, which would give me 410 degrees. That would be a positive coterminal angle. Likewise, I could take 50 degrees and subtract 360 and get negative 310 degrees as a negative coterminal angle. And I could add and subtract as many of those 360s as I wanted to. Okay? Sometimes you'll have an angle that subtracting 360 one time won't get you a negative because the angle was already more than 360. So you might have to subtract it twice or 3 times in order to get that negative value. Okay? Part B, I've got 2 pi divided by 3. I want a coterminal. So I'm going to have to add 2 pi. Well, I've got fractions. So in order to add fractions, they have to have common denominators. So I need to rethink and think of my 2 pi as really being 6 pi over 3. So that I have a common denominator. And now when I add those together, I have 8 pi or 8/3 pi radians as my angle. Likewise, I want a negative, so I'm going to subtract 2 pi. But again, I need to think of 2 pi as 6 pi over 3. So when I subtract, I get negative 4 pi divided by 3 radians. Okay? So finding coterminals is a very simple process. If it's in degrees, we're going to add or subtract 360s as many times as we need to. If the angle is in radians, then we're going to add or subtract 2 pi as many times as we need to get our desired result. Okay? So Hopefully you can digest all of that, and then we will do some practice problems with those tomorrow in class. We'll see you there.